Hi everyone, my name is Xiao. I'm going to talk about my report on surface modification of artificial knee joint. I will introduce my report from three parts: introduction, literature review, and research design. Artificial knee joint is a technology that used to replace the damaged or sick joints and let patients live a normal life. The number of patients with arthritis, osteoporosis, and covered fraction disease become more and more as people's lives get longer. These diseases bring intolerable pain and much inconvenience. Artificial knee joints are widely used to replace this sick joint and improve the quality of patients' life. The purpose of this report is to find the research of artificial knee joint and summarize the improvements of different properties after conducting the surface modification. This report will introduce improvements of properties from three perspectives: mechanical properties, wear resist, and other novel perspectives. Although the improvements of each properties was achieved successfully, there are many problems. In the future, scientists should find the material or method to enhance properties of artificial knee joint at the same time. In the process of reading the literature, I classified these literatures into three categories, and I will introduce two literatures on the mechanical properties improvement and the wear-resistant improvement. These two researches are also related to my own research design, which I will mention later. Mechanical properties of artificial knee joint can determine whether they can load the whole weight of a human body for a long time. As shown in Figure 7, Yang Huang adds ultra-low molecule with polyethylene, which works as lubricant, into ultra-high molecule with polyethylene. After mixed, the base material floats fast and form a hard crystal structures along the direction. This structure improves the mechanical properties. However, the improving of mechanical properties decreased the wear resistance of material in this research. Next, there is a study about the wear resistant property. The wear of artificial knee joint can cause aesthetic losing and fear of replacement. As shown in Figure 8, Timoro tried to reduce the wear loosen by graphing cross-linked PE with MPC polymer. The phospholipid in MPC provides hydrophilicity and works as efficient bond-around lubricant. After graphing, researchers find that the wear amount decreased by 86%, which shows an excellent improvement of wear-resistant property. There are also some researchers study the artificial replacement from different perspectives, like finding the proper thickness of insert layers, analyze the influence of tranexamic acids on the performance of replacement, observe the microstructure of diamond-like coating on replacement. Although these studies have many excellent findings, there are still many gaps. The most significant one is that the improvement of one property can cause the decreasing of another property. In this way, my design question is how to improve the mechanical property and wear-resistant property at the same time. The design in this report will combine the benefit of two materials and improve the mechanical and wear-resistant property of replacement. I use UHMWPE as my base material of replacements. First, 10% by weight UL-MWPE and 90 weight UH-MWPE was mixed in an extruder, and the pellet was got. This pellet was milled and injected into knee joint samples, which need MP UH-MWPE. Second stage, a part of MP UH-MWPE samples was put in the MPC solution, and photo-induced polymerization on the surface was conducted to achieve the graphing process. The sample in this stage was named JUH-MWPE. Finally, use compression method to produce CM-UMWPE samples as the control groups. All these samples were sterilized. Then I will measure the property of these samples. Wear-resistant property of these samples was measured by wear tester shown in Figure 10. To ensure the accuracy of the experiment, the test was conducted more than 3 times for each sample with slide time of 2 hours. The friction coefficients, friction torque, normal load, and weight loss was got by this test. The element condition of the samples for each group was analyzed by X-ray or an electron spectroscopy. The distribution of UL-MWPE and UH-MWPE was observed by polarizing optical microscopy. The hydrophilicity of samples was gauged by the water contact angles. For the mechanical properties, tensor test was used to measure yield strength, ultimate tensor strength, Young's modulus impact strength, and elongation at the break of these samples. 3 samples were tested in each test above. There are also some advantages and disadvantages in my exam. I combine the benefit of 2 materials. Then I deal with the limitation of molecule of using UL-MWPE, which cause the deterioration of wear-resistant property. However, there are also some limitations. My focus is the wear-resistant properties, and I did not do experiments about biocompatibility. I just mentioned this final material is theoretical biocompatible. Then I still have to do research about the possible of reaction and whether there are other properties get worse in this design. Then it's my reference, and thank you.